Hello guys, today we are going to build an AI chatbot with a very basic simple UI, and it will be like ChatGPT, Gemini and Claude that you usually use, but this will be your personal assistant because it won't even require an internet connection and it will run locally on your machine. For that we will be using Olama, and for the UI we are using Gradio. I'll dive deep into the details further. Now, this is the first look of your chatbot and how it will work. Let me just give demonstrate. Let me assure you that it's not using any internet connection and it's running locally on your machine. And yeah, it's works like a charm. Let's get started. Okay, so first I'd like you to make sure that you have installed Python in your machine, and then I would like you to navigate to Olama's website, and click on download and choose whichever operating system you're on and then download. I'm currently on Windows, so I will download this. I've already done that, so I'll be skipping this step. So yeah, what Olama is. So in a nutshell, Olama is a lightweight framework for running LLMs on your machine locally, and they are highly optimized for performance and they're very easy to use. Now, once you download this setup, run that setup on your machine, and after you successfully do that, you can just go to your terminal or command prompt and type Olama. This should pop up on your screen. If yes, then you have successfully downloaded Olama on your device. Now, there are two basic commands when it comes to this: Olama pull and Olama run. Olama pull command is used to download the model in your machine. There are various model Olama provides. This is the official repo for Olama, and these are the models: Gemma by Google, Llama, Meta, Phi, I guess it's from Microsoft, Lava. Now each model has their own peculiar, uh, what I can say, attributes. Llama is a general purpose model. This Mistral is a lightweight and fast, high quality performance, known for high quality performance, and is good for chat and general tasks. Whereas this Llama, these are basically general purpose LLMs. They have good reasoning, chat, and uh, completion abilities. So, in a nutshell, Olama enables users to run, manage, and interact with LLMs. And these are all the LLMs that I just mentioned, and they all run on local hardware, and they don't, of course, don't need any cloud for that. Now you can choose any one of these, but there are some limitations, of course. These are the parameters: 1 billion, 4 billion, and the size. As you can see below, minimum at least 8 GB of RAM should be available to run a 7 billion model. So, as the parameter increases, the RAM required for your local device also increases. And of course, if I want to describe parameters roughly, they are just the variables that are used to train the model. So more the parameters, that is more the variables, that more the model is intelligent. Of course, I'm giving a rough estimation, but that's how it is. For demonstration purposes, I will be downloading this 1 billion parameter model by Google, Gemma 3. And to download this model, you have to just open your command prompt and type Olama pull and that model name. Mine is Gemma 3 1 billion and press enter. I've already downloaded that model. Uh, I guess it's around 815 MB. You can just download it like that. You can choose any one of these based on your specs of the device. After you download the model, you can type Olama run and again that model name that you just downloaded. Of course, you can download multiple models. Here I am just demonstrating, so I'll be using that again. Gemma 3 1 billion parameter model. So yeah, we can just now give our prompts and it should reply to us. So hello, Gemma. Yeah, works like a charm. And to exit, you have to type this command, a forward slash by, and you'll exit. You can download as much as you want. Here are the names of the model. I use this one. You can go with the 4 billion parameter or the 12 billion parameter, anyone you want. Now, this is all good. We are running this on terminal. What about the UI? I just showed you. To create that UI, we'll be needing Python. So yeah, till now we ran our Olama model um, through command prompt. Now, how do we interact with that model using UI? For that, we will be making a Python script. So again, make sure that you have installed Python on your machine and let's get started. First, create a file. I'll name it chatbot.py and paste the code that I wrote earlier. Now, first, let's make sure that you have all the modules installed. For example, Gradio. For that, you will just have to visit its official documentation, Gradio, and beneath the quick start, you will get this. Just copy it, pip install, upgrade Gradio, and in your terminal, uh, you can paste it and press enter. Now, after you have installed this library, you if there are red squiggly lines, they will disappear. Same with requests. You can just search for it, request PyPy. From here, you can install requests on your machine. And again, if there are red squiggly lines, they will just get removed. Same with JSON. Now, why am I using Gradio and not other frameworks like Flask, Django? So the thing is, Gradio was easiest to work with. The main goal of this video was the highlight was on using a chatbot. Now I am using Gradio because this a single line creates the whole UI. It was the simplest form that I can find out there to explain you guys. Now you can use Flask and Django, but I will be going with this because it's the simplest and you can always tweak and make changes in the future. So let me explain this code line by line. First, import Gradio, of course, to import the library and its dependencies. Um, so the Gradio is basically to build the chatbot UI that we will be building. The request module here is to make the HTTP post request for the local Olama server, and JSON is to pass the streamed JSON response. Now, what is streamed JSON response? Now, before that, JSON stands for JavaScript Object Notation. It's basically a light data interchange format that's easy for humans to read and write, and easy for machines to pass and generate. Now, it's a text-based format. I've written an example here. It looks kind of like this. There is a key value pair, and it's language independent, but it's derived from JavaScript, of course. And you commonly see these in APIs, configuration files, or say data exchange. These are these are basically used on most of the places. Now let's get back to what is stream JSON response. Now the thing is, the Olama server doesn't send the whole reply at once. You can observe that when you give a prompt, the reply comes word by word. Now, you have observed that it sends small chunks of JSON data one at a time. This is stream JSON response. Each line is a complete mini JSON object delivered one by one. This is called HTTP streaming. Now, why are we using streaming? Let's say that you have entered a prompt and the model will be giving output of, let's say, 150 words. So if the streaming is off, now you can see here that I've turned it true. But if this is false, then in our UI, when the whole response is generated, then we will be output dumping that whole text on the UI, on the front end. Now without streaming, we have to wait full time. Then the whole message pops up at once. This is kind of time consuming. Not a time consuming, but yeah, we have to wait for the whole response to complete, and then we can pop that response on the front screen of the user. Now with streaming, you can get the word or phrase as soon as it's ready. Feels like it's alive, kind of. I can show you here. If I say hello, you can see that the response is generated word by word, and we are not dumping the whole text after the whole response is generated. Now this feels kind of alive. This is called streaming. Now let's get back to our code. Okay, as you can see, this is the function. The main function that calls, that Gradio calls, to be more precise, when the user sends a message. This line here adds the user message to the chat history placeholder for the assistant's reply. Now I just showed you that the user's message is appended. Now this append is just a method of the list to add the text in a list. You can see that in the history, we just go on adding the user text. Payload is nothing but this is used to create a request payload for the Olama's API. Here, this is the key value pair here. The model is Geometry that I just downloaded uh, in in my machine. You will be putting the name of the model that you will be using here, and everything else will be the same. Just here you have to make change of the name that you have downloaded the model. You'll be using that model here. The next line here is the post request. This lines here, the post method of requests sends the request to your local Olama server. I have mentioned stream as true, which means that the response comes line by line, and which is good for animation that we do. Now here comes the heart of our whole code. Please understand this carefully. Partial reply, we are creating an empty string here, and in a loop we are iterating. Now this if line, this checks the line is empty or not. This is a boolean value, as you can see here, in the loop for line in response dot iter lines. Now in the response, we if if the response is empty, then this will be empty and this will be false. So this loop will never be this functional block will never be executed. So overall, we are checking if the line is empty, because some may be just new lines or separators, right? So this avoids trying to pause invalid or empty lines. The next line here, data is equals to JSON dot loads line dot decode UTF-8. What does this mean? Seems kind of complex, right? But it's not. Let me break it down for you. Overall, this converts a raw line which is in bytes. This again, listen carefully. This converts a raw line which is in bytes into a Python dictionary. Now, how does it do so? The line dot decode here turns the binary into a readable string, and JSON dot loads turns this readable string into a dictionary, like I mentioned earlier, dictionary. Oh, just a sec. In this format, in a dictionary. Now the next line, delta is equals to data dot get message dot get content. What does it do? Here, as I mentioned, the small chunks of assistant's reply that we are getting in the form of dictionary from the above line, the data dot get message and this empty curly braces. Now, if dictionary that we got is empty, then we will be executing this part, and if it's not empty, then the message will be extracted. Similarly, the dot get content extracts the actual text. So for example, if this is the JSON format that we got, first the delta becomes hello, then the delta becomes hello, then the content there, then how, we go word by word, and so on. Partial reply is equals plus is equals to delta. This is nothing but this is similar to what we can say, partial reply is equals to partial reply plus delta. It's similar to this. And what this is doing is it builds the assistant full message piece by piece. So we are again building the full message of the assistant piece by piece. Basically, we can say that we are appending the new delta to whatever already have been received. So we are building the whole message again. Now this line history of -1 is this. -1 is basically in a string. If we want to start from the last alphabet, or what we can say the last item, then -1 is used. It's kind of an index for that string. So what this line does is it updates the last chat history entry, replaces the placeholder response with the growing assistant's reply. Now, as I mentioned, we are doing an animation thingy, so we have to append the replies. But why -1? Because history appends the message we just added. It's the last item. As I mentioned again, if this is the response from our chatbot, then to hello, this is at -1th position in a string. And the last line here, yield history, and then this. What does it do? Yield is a temporary return. Gradio uses this to animate streaming. The first history here, the first history here updates the chatbot UI that we have created, and the second history updates the internal state for context. And the last thing here, this clears the input text box, so the user's message disappears after submitting from the text box. So what's the result? We can see the reply coming word by word like ChatGPT typing it. So all this thing just to create an animation. We can say that. So next is I create a variable uh, where this I pasted this. This is nothing but a GIF that comes in a place of a profile of that chatbot that we were just using, like this here. Now I used a website for that. You can use your own, of course. Uh, this is the website. I just searched for AI and picked pick this one. You can click on this little chain type thing and copy the URL, the link, and paste on into that variable here. I have used this, and yeah, the basic code is done. Okay, with that we are completed with our basic code. I hope you understand it till now. And now let's get to our main UI building code. Now again, you can get this whole structure on the official documentation here. Uh, from your quick start page, you can navigate to the building with blocks and block event listeners. This is the basic block that we I used personally. Here. I just added some other elements in the blocks like here blocks create the blocks. The markdown is nothing but the title of your UI. The chatbot here is this whole chunk of code is all about the chatbot that, for example, we have created animation avatar. So create that profile for our chatbot, and this enables to, for example, set the size of the GIF that will be fitting inside that profile pic of our avatar. And this is just a label that I used. Ola Majid. You can put anything in here. And here, as the name suggests, is the text box. We are using this to get the prompt from the user, and this is just a label that appears inside the text box. Now, this uh, user input is stored in MSG variable. Similarly, a button is created, and it's in this variable, and state will be using this to uh, basically create a state to usually use to clear the contents of the chat that we have created. Here, msg.submit is the main line that I wanted to highlight earlier. This here, the Gradio calls this function that we have declared above and passes the message and state. Now, message is just the user input, and which is further passed to this function, and from this function is further passed to our model. Now this model works on the prompt that we have been given here, as we have shown, content message, and the state is nothing but uh, it's like a flag to check whether the user has clicked on the button or not. And this is just a lambda function, also known as an anonymous function, which is like a use and through function. And basically, this is just to initiate the whole process. Now you can change this all settings and stuff. This is just the basic code that I've created. You can take a screenshot of this or save it as you want. I'm just showing it all. This is the basic code. Of course, you have to change this name of the model that you are using in your local machine. You can use multiple models again here. And this is the whole code. You can change the GIF that you're using. Okay, so now that we have done with the code, and I know it might be kind of overwhelming for some of you people, but it will just you will get used to it by doing trial and errors, getting used to codes and all. So this is the basic code. Now let me show how to run this code. So there are basically two ways. The first one is to click on this small run button at the top right corner of your screen, and a small URL should pop up. This one. Press the control button on your keyboard and click on this URL. So your chatbot should be ready, and you are ready to chat here. Again, I should mention that there is no need to for internet uh, connection. After you downloaded your models, they will run locally on your machine. There is no need for internet. And let me see what this can do. Hey, what are LLMs? It should answer without any H. It's a basic question. Now you can choose any model you want based on the parameters. They decide their intelligence, how a model is behaving and all. For example, for some people might need image processing. I guess Lava is good at that kind of stuff. You can just Google them and see which attributes, which models are good at what, and what are their peculiar attributes. Um, you can just go with that. And the process is same. You just have to download them in your machine using Olama pull and the model name. And you can always run them in the terminal by using Olama run model name. And you can just change the names in our code also here. Now let me just stop this code. It might error out, of course. Stop this. Let me show you another way. Okay, the another way of running a Python script is from a terminal. Let me just put up a new one. And you have to just navigate to the folder in which you have created your Python script. In my case, it is in OneDrive documents, OneDrive documents, skills, and then write Python and the file name that you have created, the script name, sorry, chatbot. In my case, .py. It should hopefully run and give you this URL. Yes, hold your control key and press that URL, and again you are ready to chat with your bot. Leaving by. Oh, damn. It took me in the wrong way. But anyways, that's the 1 billion parameter model for you. It thinks that I'm depressed. Well, anyways, I hope you enjoyed this small tutorial, and we'll dive deep in for future videos like using LangChain and creating some complex models using OpenAI, ChatGPT, API keys. And yeah, I hope you enjoyed this. Thank you.